our last divisibility test is the one for 6. And the way that you do 6 is you have to combine two different rules. So you have to first see if it's divisible by 2, and then you have to see if it's divisible by 3. Okay, so that's how we're going to start. We're going to start all of these with a number 2 first. Okay, let's check our 2 divisibility rules. Remember, in order to be divisible by 2, it has to be even, so you can think of it that way. Or, in other words, in order to be divisible by 2, it has to end in a 0, a 2, a 4, a 6, or an 8. Okay, so I know that this... So sorry. Let's try it again. Okay, we're going to try that again. The computer's messing up on me. In order to be divisible by 2, it has to end in 0, 2, 4, 6, or 8. I know that this one is odd, so it is not divisible by 2. And so looking back at the divisibility test for 6, the first thing that had to be is divisible by 2. So if you get one that's not divisible by 2, it's also not divisible by 6. Okay, same thing with this one. 711 is divisible by 3, which is great, but it's not divisible by 2. And if it's not divisible by 2, that means it's not divisible by 6. Okay, the other two on the page, 1110 and 660, those are both divisible by 0 because they both end in a 0. Now, let me say that differently. It's been a long week, so sorry. 1110, 660, they both end in 0. So since they both end in 0, that means they are both divisible by 2. Okay, so they satisfy the first part of the 6 argument. Now then, let's look at the 3 argument. In order to be divisible by 3, the sum has to add to be a multiple of 3. So 1 plus 1 plus 1 is 3. So this one would be divisible by 2, since it ends in 0, and it's divisible by 3 because its sum of the digits is a multiple of 3. So that means, yes, it is divisible by 6. Okay? Likewise with 660. It ends in 0, so that means it's divisible by 2. 6 plus 6 is 12. 12 is a multiple of 3, so 3 goes into that. So 660 is divisible by 2 and divisible by 3, so yes, it is divisible by 6. And that's how that one would work. Okay, the last 2 things you have in this chapter are the greatest common divisor and the least common multiple. Now, one of the things that's really confusing about these, if you'll look at the top line, it says greatest common divisor. It's a product of prime numbers with the smaller exponent. So that's really misleading for math to say the greatest common divisor has the smaller exponent. And so it is a little confusing, so I'll give you that. All right, let's talk about it. Before we go to the definition and the procedure, let's talk about it in terms of this statement here. It's the greatest number that divides both terms. So let's just talk about easy numbers for just a minute, 9 and 15. If I look at all of the factors of 9, I have 1 times 9 and 3 times 3. Those are the numbers that go into 9. If I look at all of the factors of 15, I would get 1 and 15 and 3 and 5, and those are all of the numbers that go into 15. There we go. So when you're looking for the greatest common divisor, it's the largest number in both lists. So the greatest common divisor of this would be the number 3. And that's how you would do it if you had smaller numbers. But what if you had larger numbers? Well, that's the hard part. Okay? So let me write that back out for a second. So writing some notes there for you. The greatest common divisor of 9 and 15 is 3. Okay, it's also called the greatest common factor. Right, the other one that I want to do is 504 with 3,675. Make sure I copied them. I did. Okay, what I want to do with these is make a factor tree. So we're going to make a factor tree out of both of them. It doesn't matter which number you start with. I'm going to start with a factor 2. I know that 2 goes into this. Two times. 2 times 252 would give me 504. Okay, and so this is a prime number. Okay, so let's divide it again. I don't really know my tables that go into 252, so I'm just going to start with 2. This is going to be 2 times 126. Okay, so let's keep going. 2 goes into 12 6 times, and 2 goes into 6 3 times. Okay, you could divide it out if you needed to. Okay, I know that 63 has a 9 and a 7. I know that 7's a prime. And 9 is 3 times 3, and those are the primes. So that would be my prime factorization of 504. So if you look through there, you're going to have a factor of 2, and a factor of 3, and a factor of 7. There are 1, 2, 3 2s. There are 1, 2, 2 3s, and there's 1 7. Okay, so that's how that one would go. Okay, so let's try 3,675. I don't know what goes into it, but I do know it's a multiple of 5 because it ends in a 5. So that's how I'm going to start it. Okay, so I'm going to get 5 times 735. 5 is a prime. Okay, so then I'll divide 735. I don't know what goes into that, but I do know 5 does. So I'm going to get 5 times 147. Okay, so then I've got 147 in play. So 147 is not divisible by 2, but if I add up its digits, 7 plus 4 plus 1 gives me 12. Okay, so that means it would be divisible by 3, using my divisibility rule for 3 that we learned earlier. So divide 3 into it, and I get 49. I'm going fast with the division because I don't want to make you watch videos for a long time. So if you want to do the calculations with me, just pause it if you need to. 49 is made up of 7 times 7. Okay, and so that would be the prime factorization of 3,675. So I see my digits are 3 and 5 and 7. Okay, if I count the number of 3s, there's only one of those. There are 2 5s and there are 2 7s. Okay, so that would be the prime factorization of both. Now look back at your rule. It says if you take the prime numbers, you're going to make a list to find the greatest common divisor, make a list of all the ones that are common that have the smaller exponent. Okay, so what I notice about these is both of them do not have a 2. Okay, so 2 is not common. And so you notice it said greatest common factor, so that means you're looking at what's in both. They're not common. What they do have is they both have a 3, so that's a good thing. And if you'll look back at your rule, it says take the smaller one. Okay, there's not a 5 in both of them, so I'll mark that one out. It also says that we have a 7. They have a 7 in common, and you'll take the smaller one. And so 3 times 7 would be your greatest common divisor. That means it would be 21. And that's how it would look. Okay, let's see if we can get the multiple in this same video. Okay, the last one says we're doing the least common multiple. The least common multiple is the smallest number that is a multiple of both of the given numbers. Now, again, it's complicated because I'm telling you to do least, but then I'm looking for a bigger number. So you just got to keep them straight in your mind. Let's take easy small ones first for a minute. I'm going to take the number 9, and instead of looking for factors of 9, those would be smaller numbers that go into 9, I'm looking for multiples of 9. So that means go out your 9 multiplication table. 9 times 1, 9 times 2, 9 times 3, 9 times 4, 9 times 5, 9 times 6, 9 times 7, and so forth. I might need more than that, I might not, we'll have to see. So I'm also going to go out my 15 multiplication table. 15 times 1, 15 times 2, 15 times 3, 15 times 4, and so forth. So what you're doing, once you make your multiple list, if you had smaller numbers, once you make your multiple list, you're going to look for the smallest one in both lists. Okay, so the smallest one in both lists is a 45. And so my least common multiple here would be 45. I also want to try the numbers 24 and 27. Now the other way is to use your definition that it told you on the previous slide and use the factor trees. And these factor trees are much easier than the last example. 24. The numbers that go into 24, you could use whatever factor you wanted. I'm going to try 4 and 6. The factors of 4 are 2 and 2, and the factors of 6 are 2 and 3. Prime, 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 prime. So my numbers are 2 and 3. There are 3 2's and 1 3. Okay, so let's go with 27. The number that goes into 27 that I'm going to use would be 9 times 3. 3 is a prime. My factors of 9 are 3 times 3. So the only factor of 27 is 3, and I'm going to take it 3 times. Okay, so let's go back a slide. If you're finding the least common multiple of numbers that are a little bigger, you're going to look at your prime powers. Okay, so this means take your factor tree, and you're going to pick the ones with the larger exponents. And this time you want to list out every factor. I'll pause it just a second. Okay, so when you make the least common multiple, you're going to take, you see in here you've got 2's and 3's. You're going to take your largest 2 and your largest 3. Okay, 2 cubed is 2 times 2 times 2, which is 8. And 3 cubed is 27. So if you multiply those out, you get 56 and carry, and that's 16, 17, 18, 19, 20, 21. So it would be 216. And that would be your least common multiple of those. And that's how it would look.